All right, guys, let's start. Just to make sure you can hear me very well, right? Because I was just like switching my audio. I want to make sure that you can still hear me. Very nice. Thank you. Cool. All right. So starting from today, starting from like this lecture, we're gonna start a new session, software security. And you may have heard about this before. If you are a member of Table, if you have ever played like the actual CTF, I know that you guys already played midterm CTF, but if you also happen to play other CTF before, then you probably heard about software security. You probably heard about like those interesting things like techniques or tools that regarding software security, such as say like IDA Pro, Ghidra, or program analysis, or say like reverse engineering, like those different kind of fancy techniques and tools, those names. And it's fine that you have never heard about them because this is the whole point of this series of talks. So we are going to go through those essentials and also those interesting stuff regarding program analysis, regarding software security. And today, actually, I'm going to start with things that are essential. So it's not really about software security, but I would like to set up those necessary information or the necessary knowledge that you need for software security. And it is fine that you don't know about what I'm saying right now. But I hope that you do understand this very well after today's lecture, or maybe like within this week. If you happen to find something that you still don't understand, I highly recommend you to make yourself understand that, because those are the essential knowledge that you have to know in order to finish this part of the course, as well as the future assignment regarding software security. All right, so let's start. So outline. Today we're gonna cover four stuff. For like essential things. The first one is C. I suppose that most of you know about language C, right? I'm not sure like if C is a must for as an undergrad, but I know that most of you have at least used or heard or know the basic knowledge about C. Okay, so if this is the case, then it's good, because today I'm not going to teach you like every little step, every tiny bit about C. I would just like talk about a one thing that I think is very important, and I do hope that you understand, because we're going to be very heavily like kind of like use that or refer that for many times during our series of lecture for software security, which is pointer. Okay, so I'm going to talk about talking about pointer for C in today's class. And if you don't understand that, it's not a hard thing at all. And it's fine if you don't understand it right now. Just like Google it around, just do something like C pointer, Google it. You will get a bunch of tutorials talking about that. And give yourself some time to recall it or to learn it, so that you will be able to understand the memory notation or the pointer notation about C, about the programs, because we're going to heavily use that for software security. Okay, and then questions I see from the chat or the slides posted, or am I going to release them later? I'm going to release them later, not right now, but like I will release it probably today or tomorrow, and along with the talk, along with today's lectures video as well. Cool. All right, and then the second part is Python. I know that many of you know Python, but also some of you have never used Python before, or just like don't know Python at all. We will use Python to program. It's very likely that you will need it for your assignment. So if you don't know Python, I actually think that this week is gonna be a good chance for you to catch up on Python. I'm going to talk about basic steps of Python today by showing you an example. And if you have Python with you right now on your computer, I would like to have you to follow what I'm doing, just like do that on your computer as well, like in a meanwhile, so that you can start with your first Python program. But otherwise, do install Python because there are very good, very user-friendly Python packages that you may want to use for your assignment. And like other languages such as Java don't have a package like that, don't have a library. All right. And then a third about Bash. If you are using Windows, then you want to have a Linux machine. You want to have a virtual machine, and that will be enough. You don't have to have an actual Linux machine. Like right now, I'm using Mac, and I just install Linux as a virtual machine in my laptop. You can also just use fancier techniques such as Docker in order to have a Linux environment. And the reason why we need that is because when we talk about those binary analysis, we're going to be focused on the Linux binary, not Windows. Linux binary. We're going to talk about some formats about that, which is called ELF format. We're going to talk about those like memory layout, those binary analysis, not really strict to ELF, but like we will use ELF binary as examples to go through all different kinds of knowledge and techniques about software security. Okay, and then last but not the least is about like binary, hexadecimal, and endness. There's no programming requirement on that, but there is like those is fundamental knowledge that you will keep using it when you look into the memory of a program, when you keep doing binary analysis. So also this is like pretty essential, pretty important. If you have had an architecture class before, it's likely that they have mentioned that. And if not, which is also fine because I'm going to cover that today. But if you have any questions, again, make sure that you understand that correctly. You can also just ask me during the class. All right. Now let's continue. The first thing is about C. So I am not going to talk about like the syntax of C, but instead I want to give you like a small test. But of course, this won't be counted as any score. But like I want you to think about this question. We have this program right now, okay? And I want to answer me what is the output of this program. Cool. I am I saw answers and I saw correct answer. Very nice. All right, then let's take a look at the result. The result is book one's name, Harry Potter and the Philosopher's Stone. So many of you have answered this correctly. And let's just walk through this program together. So when I read the program, I usually start with main. Like I would just ignore those definitions or those like functions. When I say definition, it includes both the definition of functions and also and the definition or say the declaration of those variables and the type, etc. So I usually just start with main because I want to understand this from top down. Okay, so let's take a look at the main function. It's not very it's not very long. It's actually only four lines. So first is declaration. Okay, ignore it. And then it's init one, init I, Harry Potter I, right? And then it passes as there is a and sign over there and symbol. What does it mean? It means that it passed Harry Potter I, which is the variable, but it passed the address of the variable into function init_i, right? And then it changed the content over there. It like set up those contents such as the ID, the name, the author, the pages, etc. And then once this returns, the main function calls printf, right? It calls, these string. It's a format string, and it has Harry Potter 1 name as the argument passed into the format string. And that's the reason why you will be able to get like book one's name, Harry Potter, and then the name, right? And then name, which is Philosopher's Stone. All right, and then let's take a look at, okay. I think I messed up the animation, but whatever. Let's take a look at the second one. This is the program. And can anyone explain to me why is the output is like this? Oops, sorry. It also takes some time to go through the program. Yep, Colin said that there isn't a pass by reference. Exactly. So Harry Potter 2's instance is never modified. And Michael is also answering this correctly. It's not dereferenced, so we're passing a pointer, not a value. So actually, I am passing a value, but it's not a pointer. It's just a copy, exactly as Colin said. So let's go through this, okay? Again, let's take a look at the first part. We have initialization for Harry Potter to this argument, this variable, right? And then in the second statement, what it does is that it has Harry Potter, but then it copy Harry Potter, like the content of this specific variable, it copied that as another variable. And then it passes into the function called init_to. So basically here, when I say book, this book, if you look at the memory or if you look at the memory, this book, this argument called book is different from the argument called Harry Potter 2. It just like copy paste the content of Harry Potter 2, which is 0 in this case, to another argument named book, and then passed it into function init_to. So inside the function init_to, you will see this argument book, you will see the name, the author, the pages. And in fact, here, if you print book.name, book.author, book.end pages, you will get the value. However, this argument or book, book is different from Harry Potter 2. So by the time that you return from this function, even though that you don't say return 0 something, because this is a voice, so this is a procedure. But like, even though after you return that, the actual argument, which is Harry Potter 2, doesn't change. Because when it does all those assignments, assigns to a different argument or different variable named book. And that is just a copy of Harry Potter 2 with the identical content. So I'm trying to come up with a metaphor. It will sound a little bit weird, but like things, for example, all right. So for example, right now, if Tiffany, I myself is an argument, right? And then I need to attend a meeting. So let's say attend meeting is is a function. All right. So what the computer really does is that it's not really moving me to the meeting. It duplicates me. So it's like there is a Tiffany and there's a Tiffany Prime, which looks, maybe it's my twin, or maybe it's just like, someone who is identical to me, just totally exactly the same, and then puts my duplicate into the function called attend meeting. And exactly as what Kristen is showing in the chat, right? So that person who attends the meeting may start to get information from the meeting, may know new things, but I still don't know. I have nothing, related to that meeting. I have zero knowledge about that. So when that meeting finished, when you come back to me and ask, hey, Tiffany, what do you know about the meeting? I will say none. I will say, I don't know anything, because it is the actual duplicated of, like, the duplicate me goes to meeting. It's not me. So I got zero information. I have zero information about that meeting. And similarly here, you just like copy paste the argument, pass that to a function, and by the time the function returns, your argument in the main function doesn't got changed. And that's the reason why, if you look at the output, you found that Harry Potter 2.name is still empty, because you don't assign anything to that. All right, I hope that this is clear, but if it don't, please let me know. Sounds good? Cool. All right, I'm gonna continue then. And then let's take a look at the third example. Here, I want you to try to fill in the blank, okay? So again, we have a main, and what I am expecting here is that I hope Harry Potter 3 will output the correct name. Okay, so I hope that Harry Potter 3 will be assigned with some strings, some names in init3, this function. Then here's my question. How should I fill here for init3? Like, what should I do over here? And by the way, guys, I suppose you can see my mouse, right? Okay, so then my question is, what should be filled here, and what should be filled, as the function argument for init3 if you're doing initialization here? All right, I saw Marcus is giving an answer, and also Shujading, and sorry if I pronounce your name wrong, helps Marcus out, right? I also see Samuel saying, passing, like, the giving answers. I suppose what you gave is the argument for the main function. All right, so you all have an answer, and let me show the exam. Let me show you the program. Actually, let me just like finish this initialization first. So here, this is the initialization that I want to put over here. Oh, sorry. This is the initialization, and here what you want to put. Let me turn on my annotate. Hold on. Okay. So here, what you want to put is Harry Potter 3. And you don't really need the and sign here, or like of course, it's not this, because you want to pass this, like, again, you want to pass the address of this particular argument, like which points to Harry Potter 3. And here, Harry Potter 3, it is in the type of pointer. It's a bookstore, right? So it's in the point, it is in the type of pointer. So you just like pass this pointer into init3. And then in terms of the definition, just give me a second, guys. I lose my mouse. I can't move it anymore. Damn it. Okay. it back for a while and then it goes back, it disappears again. Give me a second, guys. Let me just use my iPad to connect to the meeting, and then I will use my iPad to write over there. I'm sorry about the inconvenience. Okay. So Harry Potter, this is what we feel for init 3 when we call the function. And then here, we want to put is, we want to make sure that we're passing the pointer. So init 3 should take a pointer, and which is a pointer of a book as an input, right? So what we need to put here is book star book. All right. And actually, that's the reason why that you use this. And if you go back, if I can, just 1 second, guys. I keep losing my mouse, and now there's no way for me to change the slide to like go to the next. Let me stop sharing for a while. Okay, I'm back. Sorry, guys. And then that's why, like this is going to be similar to this, right? So it's again similar to init 1. We're going to pass this as a pointer. And the only difference is that like originally we have Harry Potter 1, which is not a pointer, right? So it's just in the type of book. And now if you look at the third case here, we're going to put, because here the type of Harry Potter 3 is no longer a book. It is a book star, meaning it's a pointer of a book. So we can just like pass Harry Potter 3 as the pointer to init 3 directly. All right, and then so far so good. If so, I will continue. All right, question. Is there an easy way to know when to use X or star for declaring and references? Yes, a very good question. So here's my way to do that. So if you find star, in declaration, so this is like a declaration, right? It's not really using, it's not like assignment or something, right? Declaration. This is a so-called declaration of an argument. So whenever you see that, you found there is a star, that you know that it is a pointer. But if there is no star, it's just like a normal argument. And for the variable in the type of pointer, and if you want to change that variables like the content, such in this case it's books, those fields inside the struct of book, then you just pass that directly. So that's why you have Harry Potter without doing this. However, if you don't have that, means that Harry Potter 1 or whatever argument is the actual book and not a pointer, then you want to use this. So the and sign means that you get the address. But if you find this in assignment, for example, you have like this, Harry Potter 3, and then dot something, say dot ID is equal to a number, that means that you are doing the reference. So whenever you see assignment or like those operations, you see star, it means that you're dereferencing. Otherwise, if you see the star in a declaration, it means that you're declare a pointer. Cool. Okay, then I'm going to continue. And Samuel, if you still have questions, let me know and I can answer you. I can help you with that after the class. All right. So next step, let's talk about Python 101. And again, this is the C part, and this is a very important for us, especially for our class. So I want you to make sure that you understand that well. But if you don't, if you don't, just look at some pointer reference those part of the C. It won't take you too long, but I want to make sure that you understand that. Cool. So Python, and for Python, Simon says Python locked and loaded. Can you guys see the slide right now? Good. Okay. Um, okay. And then the next, then we're gonna talk about Python, and we're gonna work on a small projects together. And specifically, what we are going to do is we are going to write an server, a very easy server, and then we're gonna write another script to interact with the server. All right. I'm gonna pause here for a while because I want to get ready to write a Python program with me. So I'm gonna give everyone 3 to 5 minutes for you to open your Python. Maybe it's PyCharm, maybe it's like the IDE that you like the most, and prepare to write a program. Or you can use just like the normal editor. I usually just use Vim. So go for whatever you want, and then we're gonna start from there. Okay. And I'll give 3 minutes. I'll give everyone 3 minutes. All right, I saw some chat from you guys. Some of you are asking about Python, right? So yes, you need to install that on Windows. But if you have Linux, you can just use it directly because Python, I mean, Windows come with Python. So, or Python comes with Windows? No, Windows, sorry, Linux comes with Python, but for Windows, you have to install it. Right, and if you have Mac, you also have Python already. All right, and guys, right now, if you don't have it, that's fine because The video will be online. You can still do that a little, like this small practice later on once you install it. Oop. For now, you can just like watch my screen, and we can work on that together. Okay, then guys, let's gonna start. So today I am going to write a small program. I call it server.c. Let me just create a new folder, and let's start from there. It's called server.py. You can name this as whatever you want. I name it as server.py, but you can name it in other ways. But I want to make sure that you remember the name of the server because we were going to use that later. Okay. All right. And let's write that together. So first, what we're going to do is I usually like to put some comments, like a high level comments, so that I know what you are going to do. So I'm going to just write the comments first. Those are the tasks for us for this script. So the first is that I want to just like read input from standard in, and then I want to output the input that the program receives. Received from the above reading. Okay. Yep. And then it's pretty simple, right? So basically you just take what you have from the standard input and then show it. And now let's write this together. Usually what I would do is that I would write a main function for Python, although for Python you don't have to do that. Like if you just do print hello without putting like a function over there, this works. But for me, I personally would like to write a function, define a main function, and I think that is a good writing habit. So what I would do usually is have a main and put something over here. I'm gonna just write a comment so far, and let's gonna fill this later. Okay. And then let's have a statement that will make us to go to the main function. This tells Python that if you're starting the actual, like the Python's main in Python's mind, that you want to call this main function that Tiffany creates. All right. And now let's start to fill this. So first of all, you want to take the input, right? So you want to read input from standard in, and you can use a function called input. So what you could do is you can have this input here. And the nice thing for this function is that you can put a message in this input function. So, or I can put a message of here. For example, what would you like to say? CSE365. All right. And then it returns message, which is the string that you will read from standard in. And now you get this message. Good. And then followed by that, I want to print this out. Because as I said, the second step is once I get this message, I want to output it, right? So I'm going to just print it. And then print the message. Or you can make it a little bit fancier, is that you can come up with a format string, say, you said message. All right, that's it. Not very hard, huh? And I would say that actually Python's pretty friendly in grammar. So those grammar is pretty like simple. It's simpler than other languages such as C or Java. But anyway, if you don't know Python before, learning it is not very hard. Okay, so now we have this program that's called server.py, and let's try to run it. One way to run it is to just like use Python 2 or Python 3, whatever, and then run it. See here, I put some random message and it comes back with the message that I input. All right. And another way is that I want this to be called like a compiled program, right? If you remember, this is what we did when we like did for assignment 1. We have a make file, and then we change a Python to if you were submitting a Python, then you want to make it as a something executable. So you want to put this into at the start of your script, and then followed by that, you are gonna do change mode, enable the program to be executed. And in this way, then you can just do server.py directly. It's essentially the same. The name, this is not defined. Very interesting. Why is that this happened? Let me try that again. Yeah, okay, it works. All right, and where we are right now. So we have the server, and then the next we want to interact with the server. All right, so we want to write a client that talks to the server. And let's start with option number 1, which is that, let me first, again, initiate a new file called client.py. And what this program is going to do is that, first of all, let's try this first option. Run server.py, and then send string. Say, yeah, send a string to that process. And then as a client, we want to print the message received from the server. All right, so let's try this. And in this case, we're going to use a package called PwnTools. And specifically, in this case, we're going to use one specific function. It's called remote. So if you haven't installed PwnTools as a package in your Python, you want to, install that, and it will be very, very beneficial and helpful to you for the future assignment. And this is the way that you import the specific function called remote from the package PwnTool. The package name is called Pwn. All right. And again, you want to have a main function, and you want to call the main function by the time that the program is executed. All right, and now let's write this main function. So first step, we want to run server, and we're going to use this function called remote. So what we're going to do is we are going to define an argument that actually call the process. Like it will need initial. Sorry, it's not remote actually. I will talk about remote later, but for now, let's use process. We want to initiate the process. The name of the process, or say like the process will execute program called server.py. All right, and then here I want to add this process and Pwn. All right, I got a question in terms of my editor, and I don't think I'm using them, but yeah, I'm using the plain them. All right, and then the next, what we're going to do is we want to send a message to the server, to the process. And this is the reason why you call a process and then you leave this argument R over here, because in this case, what you could do is you just do r.send line. 1 second. All right. And with the message that you want, for example, I'm going to put hello here. All right. And then you can keep interact with the with the process, like get a line from the process whenever the process outputs something. So you could call a function called the receive line. And then you could just print it out. Cool. That's it. But it's not the end, because you want to close the process. So you want to make sure that after you finished it, you just no longer want this process to be like dangling over there, right? So that is for the whole program. And let me just clear this up a little bit. Because according to the standard writing standard, you want to have 2 lines in between each of the function, each of the definition. All right, cool. So this is about the client, and let's try to run it. And again, you can add the like the what is called like this thing, Sharpa, Python, right? Or you don't want to add it, that's also fine. All right, so let's try that. I don't install Pwn. Interesting. Okay, let me install Pwn. I just have a new environment here. There's something wrong. Oh, I know the reason. That's because I'm using the wrong Python environment. All right, let me just open that up and then remove this, because right now I'm using a virtual, let's see, the virtual Python environment, and that's not the one which is the user bin Python one. So here, if you do this, it will work. Here we go. Okay, so now we see those outputs, and let's just go through those outputs lines by line. Okay. So the first of all, what it does is just ignore this. This is just like a warning, or say a hinting telling you there's a new version of the package. We don't need to take care of that right now. So let's go from here. It says that it's starting a new process. Okay. And that is the time that, let me split this. Hold on. So that's the time that we initiate a process called server.py. All right. So it's this corresponds to this statement. And after that, we send a line to server.py, and then we just receive a line and then print it, right? And here is the printed line. What should you like to say? And then that's it. Because if we do server.py, the first line that we receive is what would you like to say, right? What you could do is that you could receive all, or you could do this, like print 2 lines, or use receive all, which is another function, right? Okay, so let me remove this out. Let's just keep it clean, because I just want to give you a sample here, what it's trying to say. And then you sign, and then this process send the line, hello. and then it just printed out. And after that, it closed. And this is why you see stopped process. And this corresponds to this statement, r.close. All right. Okay. So that's pretty much for the Python's client and server. And the reason why I want to work through this with you and work this with you together is because in the future class, it's likely that we will have more practice during the class, and that will require you to write a Python client. So I want you to know that this, you can just take this as a template for you to write a Python client interacting with the potential server. And then here, we write a very simple server that is written in Python, but in the future classes, those kinds of server can be written in C. It will be like in a compiled code, we call it binary, meaning that it is an executable file, but it is a compiled output, a compiled program compiled compiled from a source code written in C. So you want to use Python or any other kind of language to interact with the server. But I would say Python is probably the easiest way, especially that now you have a template. So I do hope that this will help you in your future in-class practice. And you also may need that in your CTM. We're not quite sure about that, but at least for class practice, this will be very helpful. All right. So let me go through the chat. I saw Jack and Brenton has the problem. Like Elf Tools, there's an exception about that. I'm not sure why that happened, and this may, it depends on the platform that you use. And if you keep having this problem, you want to Google it, or you can just come to me during my office hour and I can help you resolve that. And question about server.py, can we see that? Yes, for sure. Let me just show it here while I'm going through the other questions. Cool. All right. That's it for Python 101. And we're a little bit behind the plan, but it is fine. I think this is very important, and I do want you to make sure that you do this. You hands-on, you make your hands dirty, and then program a little bit so that you will understand how to make this right, and especially that you will be using this heavily throughout the software security session. All right. Now let's go back to our next schedule, which is about Bash. So Bash, we're going to continue to doing something like this, but instead of writing program, we're going to try to run some of the command. All right, and let me I'm checking if I should share my slides, and maybe not, because we're going to continue using this command line and show you how you can run those server, like run that an actual server, meaning that it's going to be a server that runs in this machine, that other people can connect to the machine, like as a client, as a server, like really listen to the port in an easy way, and then you can have client to interact with that. And if you are using a Linux machine right now, you can follow this with me together. I'm going to use some of the command from Linux, and turns out that if you have those commands, you run the server, it's going to be very, very simple. It's going to be just like one line command. Okay, so let's first start with one command called socat. Socat. Let me do help. There's no help. Oh, it's option. Right. Okay. It's socat is a kind of like sorry, 1 second. Yeah, so SOCAT is like a server thing, or say it's like a very simple service called like I think a socket cat, basically. Yeah, so it's like command line based utility that can establish a two bidirectional byte stream and transfer data. So for us, what you need to do is that you can just use this command, which I will show that in the slides, so you don't have to remember it, although it's not very long. So it's called SOCAT. Actually, I already typed it here before. And SOCAT TCP. All right, this command is called SOCAT TCP listen with a specific port. That is the port number that I'm going to listen to, like the server will listen to, and then followed by two options, reuse address and a fork. And followed by that is the actual like program that you want to execute. If your server named server.py, same as me, then you can just make this run. Otherwise, we want to change this name. So let's try this together. Okay, so now the server is running. It's very, very simple. And then on the other hand, you can connect to the server as a client. What you could use is netcat, or short for NC. All right, and then what you do for NC is that NC with the local host, and then with the port. Here, in this case, it's 999. Let's try that together. Okay. So here is that, like, what would you like to say? We got that, right? There is a problem saying something weird. Let me see if I can fix that very quickly.
I think the problem is that you're running Python 2, but you want to be running Python 3.
Yes, thanks. That's a very nice catch, because here the like the system default Python, I believe, is Python 2. Thank you.
Yeah,
Let me
I
try
had the
that
exact
again.
same thing happen on my Linux thing.
Yep. I think this should suffice. All right, let's try that again. Here we go. So it's still the same command. And then on the other terminal, on another tab, I do NC to connect to this machine, which is my machine. So just use localhost, right? And then followed by the port number and use it in interaction. We put something random over there, and it's done, right? And the client finished because that is the entire interaction with the server. But you see the server still keeps running because the server is going to be waiting here for another connection. All right, so this is a command SOCAT. You can use that. And then in your future assignment, or it's not really assignment, but like in class practice, what we would do is we're going to open a server for you to connect. So you can use NC to connect or use the client script to connect, right? And also we're going to give you the binary. We're going to give you this executable program like server.py or other like an actual server written in C. And then in your local environment, if you want to test, you want to make sure that you connect to that correctly, you can use the commands such as SOCAT that you can set this server up very quickly in your environment and then try to connect that. Okay, so this is approach number one. And another approach is using what is called XINET D. But for XINET D, you have to have a configuration file. I'm going to give you a quick overview of the configuration file. Service.com. It's I mean, there are a couple of lines over here, but it's not hard to understand it. So you define the service, you give a name, and then you say the socket type you want to make a stream, and the protocol is going to be a TCP protocol. And then you don't want the service to wait. Whenever someone logs or say connects with the service, and then the service will start to call server. Whenever the server is running, it's going to run as the like the server. This program will be run with the enter the username of nobody. So there is account, this name is gonna be nobody. And then we're gonna bind this to our local machine. So it's gonna be this address. The server's location is here. This means that whenever a client is gonna be connecting with the server, we will call this specific program, start to execute this program, and then use that program to interact with the client. And the type is unlisted because we just have a self-customized server. It's not really a standard like HTTP or something like that, right? And then this is important. This is like the port that you want to connect to, or you want to set up, you want to listen to. All right. And then to run the AxNet-D, I hope that I have this here. Nope, but it's fine. To run that, it's not hard either. And I will have this command in the slides as well. So what you want to do is you want to do AxNet-D, and then followed by the configuration file using -f, specify that. So here it's in the demo service.conf. Here we go. All right, guys, I got it. So if you have this configuration, and don't worry, like you can't remember this, I'm going to also paste that in the slide so you will be able to see that from the slides. So if you have this configuration and then use this command, you also get that from the slide, and you will be able to run this server. And then you can use nseed again to connect with that, or you can use the client script that you just write. And let me show you how to do that. So what you could do is you can use your client, and that's why we want to use, I talk about remote, because what you could do is instead of call a new process, you can do remote connects to the address, which in this case is localhost with the port. Okay, now let's try this, guys. So we're going to use our client. Cool. See, we got that because we sent the message hello to the server and we got that back. And again, the way that we work is that we use this remote function so that we connect to the server, which is this panel, and that server is listening to port 6666, right? And then we send a message, we receive the message back, and we print them out. All right. So far so good. I guess it is. If you have any questions, let me know. And then let me just go back to the slides. All right, so this is what I have to talk about SOCAT, right? And also I talk about AxNet-D, you could use that. And here, file log, it just means that, you want to log this error, just like what I did, right? Sometimes you need it because you just realize that something wrong, you don't know where it comes wrong. So you want to have a log so that it will tell you exactly why it is wrong. Okay, so this is pretty much that we have for the Bash 101. I think this will be sufficient, plus those that you have had for bandit tasks. All right, and then the next is about byte and endedness. Unfortunately, we won't have enough time to go through that today. So I'm gonna just do as much as I can, and then we will have a follow-up in the next time. All right, so I suppose everyone knows about binary. And here, when I say binary, it's not the binary program, but like the binary numbers, 0 and 1. And then if you look at the program, then there are like a whole bunch of 0 and 1s. And this is actually the reason why we call an executable program binary, because It's exactly 0 and 1s. And also, because of this like so tiny thing, 0 1 0 0 1, it's just so in detailed, so like kind of like fine grained, and want to have a little bit higher level, a little bit more abstract, which is also the smallest unit to a memory. We call it a byte. So 1 byte is composed of 8 bits. I'm pretty sure that many of you have heard about that or say know about that. Okay, so those are the so-called byte. And as I said, a byte is equal to 8 bits. And then a question is, if you have a bit, then how are we going to look at bytes? So if you have a bit, and then also you have this bit position from 0 to 7, you have this 0 0 1 1 1, or like a lot of 1 and 0. And the way that it converts from a bit to a byte is that it will first look at like the higher, say like the higher position, first 4 bits, and then you will get a value, right? And it will get in like a hexadecimal value, or say we'll just call it a hex for short. In this case, if you look at the first, like from the 7th bit to the 4th bit, the first, like the highest 4 bits, you will get hex A. And then if you look at this lower 4 bit, 1 1 0 0, you will get C, because this is the low bits and this is the high bit. So you count from the higher bit, and then you count from higher to the lower. So higher is the like more significant bits, and the lower position will be the low significant bits. So here you get A and you get C, and then we are going to use hex AC to represent this sequence of bits. All right, so this is usually the way that we represent a byte. And you will see like a byte is say AC, hex AC, or say hex maybe 1 2 hex 5 4, whatever. And then if you convert that to bits, you will see the way that it converts is you look at the first one. This is actually the high level one, right? So this is the higher 4 bits. And then if you look at the second one, it's going to be the lower 4 bits. All right. And then what if you have a char? We usually convert a char to an actual like a number, right? So the way that we represent a character is through ASCII, which is called American Standard Code for Information Exchange. So we convert a character to a byte. And in this case, if we have character A, then character A is in those kinds of bits. And then in this bits, the first 4 is hex 6, right? And then the lower 4 is hex 1. And then we just put 6 1 together, make 6 as the higher one because it's it's higher in the memory, and we got hex 61. All right. And then what about a string? What about, for example, a string with 2 characters? What about a string with 2 characters? How would it look like in memory? And how do we usually represent it? I'm going to leave this for next lecture. All right, that's pretty much for today's content. If you have any questions, let me know now. I'd like to stay here for a while to answer your questions. Otherwise, I will see you in the next time. Bye.
Hello. I have
Hey,
questions.
yes,
Uh, so can I see the client and server.py again?
yes.